The birth of a Merkava Mk.4 begins in the white heat of the blast furnace, where ballistic steel is refined to a perfect liquid state. The molten metal is channeled into a single-piece mold designed to create the Merkava's signature monolithic lower hull. This casting process eliminates structural weak points, providing a foundation that can withstand the most extreme kinetic impacts. Special attention is paid to the forward compartment, uniquely designed to house the engine as a secondary layer of crew protection. Every channel and cavity within the mold is precision engineered to ensure uniform thickness across the entire ballistic structure. Complex internal geometries are formed using specialized cores, allowing for the integration of the tank's hydropneumatic systems. Once the mold reaches capacity, the liquid steel undergoes a settling process to remove any microscopic air pockets. Impurities are meticulously removed, leaving only the highest grade high-strength steel for the final hull. Controlled cooling begins. This phase is critical to achieving the specific crystalline structure required for ballistic resilience. As the temperature drops, the steel undergoes a molecular transformation, hardening into a formidable armored shell. The molten genesis is complete. The liquid fire has become the unyielding bone of the Merkava. The manufacturing floor prepares for the extraction of the massive casting, weighing dozens of tons. For the first time, the iconic shape of the Mk.4 hull emerges from its subterranean birthplace. The temporary casting supports are discarded, revealing the precision cast engine bay and crew compartment. Initial finishing begins immediately, removing excess material from the casting process while the steel is still malleable. Precision cleaning of the internal steel pockets ensures a perfect molecular band for the upcoming inserts. Alignment is verified to within microns, ensuring maximum kinetic energy dissipation across the armor surface. Modular steel plating is layered over the ceramic core, creating the first stage of the multi-layered defense. The high-pressure hydraulic forge activates, exerting hundreds of tons of force to laminate the layers. Thermal bonding fuses the ceramic and steel components into a single indestructible composite unit. Post-bonding inspection reveals a perfect molecular interface essential for structural integrity. Reinforcement proceeds to the critical side skirt zones, where modular armor provides vital flanking protection. A secondary alloy mesh is integrated into the side modules to provide multi-hit capability against shaped charges. Precision laser welding seals the outer shell, encasing the composite materials in a steel cocoon. Rapid cryogenic cooling stabilizes the crystalline structure of the armor, preventing stress fractures. Non-destructive X-ray testing but confirms the absence of internal voids or delamination in the composite core. Surfaces are ground to sub-millimeter tolerances to ensure the modular armor blocks fit perfectly. The frontal glacis receives its final high-density compression, completing the tank's most impenetrable section. With the ceramic core successfully infused, the Merkava's hull is now a formidable fortress ready for engine integration. Preparation begins in the forward compartment, where every surface is treated to withstand extreme mechanical stress. Precision alignment is critical. The engine's position is measured to within fractions of a millimeter. This forward engine configuration is a unique design choice, prioritizing crew survivability above all else. High torque fasteners secure the powerhouse, ensuring it remains a stable shield even under intense fire. Reinforced fuel lines are connected, designed to remain intact during the violent vibrations of cross-country movement. Advanced cooling systems are installed to manage the immense heat generated by 1,500 horsepower. Desert-ready air filtration ensures the V12 breathes clean air even in the thick of a dust storm. The exhaust is routed specifically to minimize the tank's thermal signature from the front. A secondary armored bulkhead is installed, providing a final layer of protection for the tank's occupants. Structural integrity is reinforced, fusing the engine's housing into the very skeleton of the hull. The transmission is primed, ready to translate raw torque into battlefield mobility. A final digital sweep confirms that every component is perfectly seated within the chassis. The forward heart beats for the first time, proving the machine's power and reliability. With the engine secured, the Merkava Mk.4 now possesses its most defining characteristic, a shield of steel and power. The integration of the main armament begins with the precision lubrication of the turret ring assembly. The Mk.4 smoothbore gun, a masterpiece of ballistic engineering, is positioned for mounting. Engineers oversee the insertion of the breech block designed to withstand extreme chamber pressures. The precision crane lowers the entire artillery assembly into the reinforced turret cradle. The dual recoil buffers are installed to absorb the immense energy of the 120mm discharge. The barrel is perfectly aligned with the turret mantlet using high-precision laser telemetry. Forged steel trunnion pins are seated, creating the pivot point for vertical elevation. The elevation actuators are engaged, linking the gun to the computerized fire control system. The bore evacuator is fitted to prevent toxic propellant gases from entering the crew compartment. Initial elevation tests verify the mechanical range of motion for the smoothbore system. Depression limits are tested, crucial for the Merkava's hull-down combat tactics. Optical and laser range-finding sensors are aligned with the gun's primary axis. The turret is permanently mated to the hull, securing the smoothbore fist to the chassis. Fiber optic data lines are connected, providing the high-speed throughput required for millisecond threat detection. The first of 4 ELTA radar antennas is seated, forming the eyes of the tank's defensive perimeter. Symmetry is vital. The second radar unit is installed to provide full frontal hemispherical coverage. Laser-guided alignment ensures there are no blind spots in the radar's 360-degree field of view. With the fourth panel in place, the trophy system achieves total situational awareness around the hull. The central processing unit, the brain of the active shield, is housed deep within the turret for maximum protection. The interceptor magazines containing the hard kill countermeasures are prepared for docking. The magazines lock into the launchers, establishing a physical link to the fire control system. Servo motor calibration begins, ensuring the launchers can track incoming missiles at supersonic speeds. Dual launchers provide redundant protection, allowing the Merkava to engage multiple threats simultaneously. Main power is routed from the tank's V12 engine generators to the high-draw APS capacitors. System handshake complete. The software synchronizes the radar data with the interceptor firing solution. The trophy integration is finished, transforming the Merkava Mk.4 into an impenetrable armored fortress. The transformation into a network powerhouse begins with the installation of high-speed fiber optic data buses. These cables form the backbone of the Digital Army Battle Management System, allowing instantaneous data transfer. The main processing core is secured within a hardened, shock-resistant housing to survive the rigors of the battlefield. Thermal management is critical for maintaining peak electronic performance during prolonged, high-intensity operations. The crew interfaces are mounted, providing the gunner with a comprehensive digital tactical picture. The commander station is integrated, merging sensor feeds into a unified command and control interface. External communication arrays are linked, connecting the Merkava to the wider digital army network. External situational awareness cameras are synced, eliminating blind spots for the driver. System diagnostics verify the integrity of the networked architecture across all crew stations. Transitioning to the rear, the unique clamshell door system begins its mechanical integration. High-pressure hydraulic pistons are installed to facilitate the rapid opening and closing of the rear access. The lower ramp is fitted, creating the unique exit path for crew evacuation or infantry support. Industrial-grade seals are applied to ensure the rear compartment remains NBC protected and watertight. Digital sensors are integrated to alert the crew of the door's status via the battle management system. Reinforced locking lugs engage, securing the rear portal against external kinetic threats. The digital nervous system is now fully online, transforming a mechanical titan into a network predator. Before the skin is applied, ionized air purifies the ballistic steel of every microscopic impurity. A zinc-rich primer creates the essential bond between the steel and its future thermal defenses. Rapid UV curing ensures the base layer is chemically locked, preparing for the infrared reflective coating. The infrared reflective base coat is applied, designed to scatter thermal energy and minimize the tank's heat signature. Atomized pigments are layered with precision, creating a surface that mimics the spectral properties of desert sand. Critical sensors are protected as the final protective layers are prepared for application. Non-linear patterns are introduced to break up the tank's silhouette against the shifting dunes of the Negev. An anti-slip texture infused with ceramic beads is applied to the top surfaces, ensuring crew safety during high-speed maneuvers. Validation begins. The IRR coating is tested to ensure it masks the internal heat of the machine from enemy sensors. On the factory floor, the 600mm heavy-duty tracks are laid out, ready to support the 65-ton Fortress. The drive sprocket engages, beginning the process of wrapping the tank in its massive steel shoes. A hydraulic winch pulls the multi-ton track over the return rollers with calculated force. The track tensioning system activates, extending the idler wheel to achieve the perfect balance of flexibility and grip. The hydropneumatic suspension adjusts instantly, compensating for the weight of the new steel tread. Every bolt is torqued to precise specifications, ensuring the tracks can withstand extreme cross-country stress. The first rotation, the 600mm tracks move with a rhythmic power that signals the tank is ready to crawl. The Merkava Mk.4 stands complete, a desert-colored predator, armored, tracked, and ready for deployment. Validation begins in the crucible of the Negev, where the terrain provides the first true test of the Merkava's structural integrity. Vertical obstacle clearance and steep grade navigation confirm the torque efficiency of the GD-883 power pack. Agility testing ensures the tank can maneuver within the confined, treacherous spaces of a mountain pass. The 600mm wide tracks are evaluated for ground pressure distribution and link durability. Engineers monitor the low ground pressure profile, essential for maintaining mobility in shifting dunes. The structural wells of the front-mounted engine compartment are stressed to simulate the violence of modern combat traversal. A simulated incoming threat is launched to validate the system's detection-to-intercept latency. The battle management system identifies the threat trajectory in milliseconds, calculating the optimal intercept point. The high-precision launcher slews into position slaved to the radar's tracking data. The Mail-Ruach interceptor is deployed using a matrix of small projectiles to neutralize the threat at a safe distance. The interception is successful. The incoming missile is destroyed before it can contact the modular armor skin. Post-intercept, the vehicle maneuvers through the kill zone, its thermal signature suppressed by infrared reflective paint. Proving ground sensors log the data confirming the trophy system's 100% interception rate. Physical and electronic trials complete the individual unit transitions from a factory machine to a combat-certified asset. The trial by fire is over. The Merkava Mk.4 is now ready for deployment to the front lines. The heart of the digital fortress awakens as the battle management system initializes its high-speed processing core. Integrated L2 radar sensors begin filtering environmental data, identifying potential threats through solid urban obstructions. The advanced fire control computer isolates the target, calculating environmental variables and distance in milliseconds. Precision inputs allow the operator to manipulate the massive turret with the delicacy of a surgeon's scalpel. Moving into a hull-down position, the tank minimizes its profile, leaving only the reinforced turret exposed to the urban corridor. A precision laser rangefinder calculates the exact distance to the target, feeding the data directly into the ballistic computer. The trophy. APS interface enters active mode, creating a protective hemispherical shield around the vehicle. The system compensates for target speed and wind velocity, ensuring a first-round hit probability regardless of movement. Multi-spectral imaging pierces through smoke and light cover, revealing hidden combatants through their thermal signatures. High-torque gyro stabilizers isolate the main armament from the vehicle's movement, maintaining a rock-steady aim. Real-time data networking links the tank to overhead Heron drones, sharing a god's-eye view of the battlefield. Human intuition and machine precision merge as the commander prepares for the decisive engagement. From its concealed position, the Merkava monitors every alleyway and rooftop, a silent sentinel in the concrete jungle. The transition from simulation to combat readiness is complete. The Predator is now the master of the urban domain. Technicians monitor pressure fluctuations, ensuring the system can still handle the extreme vertical loads of cross-country maneuvers. The heavy-duty tracks undergo tension testing, compensating for the wear and tear of abrasive, rocky terrain. Ultrasonic and laser scanners sweep the hull, detecting microfractures in the ballistic steel that are invisible to the naked eye. The internal mortar system is replenished, providing the crew with organic tactical smoke and illumination capabilities. Damaged armor modules are swapped in minutes, a testament to the Merkava's design for rapid battlefield sustainment. The Digital Army Battle Management System re-establishes high-bandwidth links with overhead Heron drones for real-time intelligence. With the rear access doors sealed, the crew compartment is fully protected, against CBRN threats and kinetic impact. The fire control system undergoes a final self-calibration, aligning the thermal sights with the 120mm smoothbore gun. The infrared reflective coating is inspected, ensuring the tank remains a ghost on the thermal sensors of the enemy. Deployment begins. The Merkava takes its position as the tip of the spear in a coordinated multi-domain assault. Built for survivability and engineered for dominance, it stands as the ultimate synthesis of armor, firepower, and intelligence.